Hello everybody, this is Skill 22B, which is the last lesson that we're going to look at that involves logarithms. Okay, and so today's lesson is going to be about how to solve logarithmic equations. So similar to what we did when we talked about exponential equations, I want to remind you all that logarithms and exponentials are inverses of each other, which means they undo each other. So just a little quick practice with that. I want to make sure that you know how to convert logarithms to exponentials. So I have this logarithm, log base 2 of x minus 5 equals 4. Since I know that my base is 2, I'm going to write this as 2 to the power of, now remember that in a logarithm, what it equals is the exponent. And exponentials are equal to the argument, x minus 5 being the argument. Okay, so remember it goes base. This will become the exponent. And this is the argument. Okay. So in the next one, remember this one, this says log. It doesn't have a base written. So remember this is a common log. And it has a base of 10. So when that happens, I write this as 10 to the negative 1 equals 3x plus 1. Next one is a natural log. And I know that because I see ln as opposed to the word log. And remember, it has a base of e. So I'm going to write this as e to the third equals 2x minus 5. Then the last one, this is just saying, so my base here is 0.5, so I have 0.5 to the 6th power equals x. Okay? So if we're able to take a log equation and rewrite it as an exponential, we can simplify the exponential parts using our calculators and then solve for x, because now it becomes a linear equation. Alright, so let's start with the steps to solving a logarithm equation. So the first thing you want to do is isolate the logarithm on one side of the equation. So if you only see one logarithm in the equation, you're going to isolate it. Then you're going to convert the equation to an exponential, and that's what we just did practice with up in that chart above. So this was us doing that conversions up here. Then you're going to solve your equation, and then we always want to check for extraneous solutions. Okay, so just like when we're in school, I want you to think of negative logs being bad. Okay, you don't like getting negative logs. But we know that positive logs, or commendations as we call them, are good things. So anyway, if you have an answer choice when you're solving these out that makes any of the logarithms negative, we're going to exclude those. Okay, so you have to check your answers. Okay, so this step is important, or it might lead you to an incorrect answer. Alright, so following those steps, I'll leave them here for us to refer to. The first question, let me use a different color here. First one says 2 times the natural log of x equals 18. I need to get the natural log of x part by itself. So to do that, what I have to do first is divide by 2 on both sides. That gives me natural log of x equals 9. So I did step 1. Next step, convert this to exponential. Since we have natural log, we know it has a base of e. So e to the 9th equals x. Okay, so that's step 2. Step 3 is going to be to use our calculator. So we're going to use e to the 9th. Remember, on your calculator, to get e, you hit the second button and then hit the ln button. And that gives you e to the power of, and then you just type in 9. And you get that x is about equal to 8103.084. Okay. Next one, we have to do 2 things to get the log part by itself. So I have to first subtract 7 from both sides. That gives me negative 3 times the log of 10x equals 6. Okay, then I'm going to rewrite this. I'm going to divide both sides by negative 3. And I get log of 10x equals negative 2. Okay. Now that 10x needs to be in parentheses. I should put that as such. And so now we have this equation. Remember, this doesn't have a base number written here, so this is a common log. So it has a base of 10. So we're going to write this as 10 to the negative 2 equals 10x. And then to solve it, 10 to the negative 2, I'm just going to put that in a calculator. That gives me 0.01. Now I'll divide both sides by 10. And I get 0.001. Okay. And there's my answer. Alright, for the next one, on this one, in order to isolate this log right here, what we're going to have to do is, well, we're going to convert this to an exponential because the log's already isolated. So I'm going to write this as 5 to the power of 20 equals x to the 4th. And I know you might be thinking, I don't know how to go about solving this, because 5 to the 20th, if you put that in on a calculator, you get a ridiculously large number. The goal is to get x to the 4th by itself. So what we're going to do, and this is a skill that you might have to recall in your mind, is we're going to raise each side to the power of 1/4. It's the same as taking the 4th root of both sides. The 4 and the 1/4, when you multiply those out, just gives you 1. 20 times 1/4 is going to be 5, so we have 5 to the 5th, and that, when you put in on a calculator, is much easier. Okay, so there we go. Alright, the last one, divide both sides by negative 3. This isn't the last one, but this is the last one on this side. So we get natural log of x equals 8. So remember, natural log is a base of e, so e to the 8th is equal to x. Figure out e to the 8th, I'm going to use my calculator, and it's about 2980.958 when we round to 3 decimal places. Okay? Alright, so that's how you solve log equations that only have one logarithm in it. Okay? The rest of our notes are going to talk about what do we do if we have logarithms on both sides of the equation, or we could also talk about what happens when we have multiple logs on one side of the equation. Okay, so first of all, if we have a logarithm on both sides and it's already condensed, so this theorem works if condensed already. So again, b is greater than 0 and not equal to 1. So if I have log base b of x and it's equal to log base b of y, this equation is true if the argument x and y are set equal to each other. Okay? So basically what it's saying is if both sides of your logs have are written so that they have the same base, so they have to have the same base to do this, you set the arguments equal to each other. Okay? Now you may have to condense logarithms on one or both sides before you can solve. So I want to review those properties with you real quick. Product property says if you're adding two logs with the same base, you multiply the arguments. Quotient property says if you're subtracting two logs with the same base, then you divide the arguments. And the power property, if you have a number being multiplied to a logarithm, that number being multiplied becomes the exponent on the argument. Okay? So we're going to try 4 examples here where we're going to do some condensing and then use the theorem where we could set the arguments equal. So looking at example A, the left side I'm going to have to condense, and I see a minus sign in between. So I know This will be written log base 2, and I'm going to have a quotient. 10 will be on top, x minus 4 will be on the bottom. The left-hand side is log with the same base of just 5. Okay? So when that happens, we can apply our property where it says that we could just set our arguments equal to each other. So 5 equals 10 over x minus 4. To make this a little easier, I'm going to put that over 1 and cross multiply. So 10 equals 5x minus 20. I'm going to finish solving this up here. Add 20 to both sides, so 30 equals 5x, and 6 will equal x. Now, before we're sure that this is correct, what we want to do is check and make sure that when we plug in 6 to a log, so when I plug in 6 here, is that log positive still? And the answer to that is yes, it is. So x equals 6 is our correct answer. All right, next one we're going to do here is going to be, so I don't have to do any condensing. I just set the arguments equal to each other. So x squared plus x equals 20. And I know I can do that because I have the same bases. Well, this is quadratic, so I have to make one side equal 0. So I'm going to subtract 20 from both sides. And now I'm going to look and see if I can factor x squared plus x minus 20. Well, I know to get negative 20, I can multiply negative 4 and a positive 5, and they'll add to positive 1. Okay? This is a shortcut factoring, so I could just write x minus 4, x plus 5. And now I know that my zeros, this will be 4, and this one will be negative 5. Let's double check and make sure that none of these give us let's see if they both give us positive logs. So let's plug in 4 here. So 4 squared plus 4. I think that's safe to say that works. If I plug in negative 5, so we have negative 5 squared plus negative 5. Well, negative 5 squared, remember that's still positive. So positive 25 plus negative 5, that one's going to be positive as well. So both answers do work this time. So remember, it's not if an answer is negative that makes it not work. It's if the log becomes negative when you plug it in. So this answer would have both. So on Haiku, or on your Google form today, you type 4, comma, negative 5 as your answer. Okay. This next one, I need to condense these. So I see a plus sign, so I'm going to have log, and then I'm going to multiply x times x minus 3 equals log 28. Both logs are the same base, so I just do x. I'm going to go ahead and distribute this. So x squared minus 3x equals 28. Again, we don't want to have, it's quadratic, so we don't want to have one side not be 0. We're looking for two numbers that multiply to negative 28 and add to negative 3, so that's going to be negative 7 and positive 4. So this will factor as x minus 7, x plus 4. My zeros, that'll give me 7. This will be negative 4. Well, I think it's clear that in this case, if I plug in 7 here, we're good. And if I plug in 7 here, 7 minus 3 is 4. So 7 definitely works. Negative 4, if I plug it in this first one, oh, that makes that log negative. It's out. So the only answer you would put in on your assignment would be 7 if this were the assignment problem. Okay, last one here, same idea. So we're going to condense these. I see a plus sign in the middle, so it'll be natural log of x times 5 minus x equals natural log of 6. Since both sides have the same base, I'm just going to go ahead and distribute this. I get 5x minus x squared equals 6. If I rewrite that, that's negative x squared plus 5x minus 6 equals 0. Usually we like to keep this leading coefficient positive, so what I'm going to do is divide everything by negative 1. And that gives me x squared minus 5x plus 6 equals 0. So two numbers that multiply to 6 but add to -5, well, that would be -3 and -2. So this will factor as x minus 3, x minus 2. This gives me 3, this one gives me 2. And it looks like both of those answers do work when I plug them in. So if I plug in 3 here, I'm good. And if I plug in 3 here, I'm good. If I plug in 2 for each of those, still good. So those are my two answers. And so now you should have enough practice here that you can go ahead and work on your independent homework assignment.